Hello, chemistry students. We are going to continue our talk on compound stoichiometry and more specifically multi-step dimensional analysis. Now we were talking about single-step dimensional analysis where we convert grams to moles, and then we talked about two-step dimensional analysis when we converted from atoms to grams, or grams to atoms, or grams to molecules. Now we're going to talk about multi-step. Now we're going to do 3 problems in this video. First one, how many carbon atoms are there in 16 grams of glucose? So we're looking for the number of carbon atoms, and we're given 16 grams of glucose. Okay, now the first thing we're gonna do is draw a map for ourselves. So we start out with grams of glucose. I'm gonna put C6H12O6. And we are going to go to moles because we always go to moles first. At the heart of anything is the mole, and in chemistry we always convert to moles before we convert to something else. So we're going to go to moles of glucose. Once we get to moles of glucose, we can go to just about anything. Now we're looking for carbon, not glucose, and there are 6 carbon atoms in glucose. So we're looking for the number of carbon atoms, not the number of molecules of glucose. But if we have moles of glucose, we can find moles of carbon. You are allowed to go from moles of one substance to moles of another substance. And then once you're at moles of carbon, you should know by now we can go to carbon atoms using Avogadro's number. So then we're going to go to atoms of carbon. We start with the grams. We're going to convert it, grams of glucose, we're going to convert it to moles of glucose, then we're going to convert that to moles of carbon, and then atoms of carbon. We're starting with 16 grams of glucose. So I'm going to write that down, C6H12O6. I'm going to draw my grid here. And we are going to go to moles of, now we're going to go to moles of glucose. Now we need to get rid of this grams of glucose, so I'm going to take it and I'm going to put it down here. If we have one on top and one on bottom, they cancel out. Now you need to find out grams per mole. That tells us that we're going to put a molar mass here, and it's the molar mass specifically of glucose. And the molar mass of glucose is 180.18 grams in 1 mole. Now we have a grams of glucose on top and a grams of glucose on bottom. They cancel each other out, so they just go away. We have now converted to moles of glucose, and we now need to go to moles of carbon. Now, so I'm going to put moles of carbon up at the top. We need to get rid of this moles of glucose, so I'm going to put it on the bottom. Now we have to ask ourselves, how many moles of carbon are in moles of glucose? Well, we can tell that by just the chemical formula. For every 1 mole of C6H12O6, so for every 1 mole, we have 6 carbons. So for every 1 mole of C6H12O6, we have 6 moles of carbon. Now we have moles of glucose on top and moles of glucose on bottom, so they cancel out. So I'm going to go ahead and mark them out. And we have now converted to moles of carbon. So we are right here at this step. After we convert to moles of carbon, then we need to go to atoms of carbon. So I'm going to put atoms of carbon up top. I need to get rid of this moles of carbon, so I'm going to put that on bottom. Now atoms per mole, that should tell us that we're going to use Avogadro's number. And Avogadro's number is 6.02 times 10 to the 23rd atoms in 1 mole. Now we have a moles of carbon on top and a moles of carbon on bottom. So moles of carbon divided by moles of carbon is 1, so they both cancel out. Now all we have to do is multiply 16.0 times 1 times 6 times 6.02 times 10 to the 23rd, and then we divide that number by 180.18, and that will give us our answer. And that happens to be 3.21 times 10 to the 23rd atoms of carbon in 16 grams of glucose. Next problem. If a sample of aluminum sulfite is known to contain 4.55 times 10 to the 23rd atoms of aluminum, what is the mass of the entire sample of aluminum sulfite in grams? So we're looking for aluminum sulfite and the mass of it in grams. So that's what we need to end up with, grams of aluminum sulfite. And we start with the atoms of aluminum. The first thing we're going to do is tell us what we start out with, and that is atoms of aluminum. Now we know we always have to convert to moles. The first step is convert to moles of aluminum. Once we do that, now we can convert to anything else. Moles of aluminum, we need to end up with aluminum sulfite, so now would be a good time to convert to moles of aluminum sulfite. Hopefully by now you know that aluminum sulfite looks like Al2SO3. Now after we've converted to moles of aluminum sulfite, we need to go to grams of aluminum sulfite. This is the map that we're going to use. We're going to start out with atoms of aluminum, then we're going to convert to moles of aluminum, then we're going to convert to moles of aluminum sulfite, because we can always go from moles to moles of something different. And then after that, we're going to go to grams of aluminum sulfite, because we can always convert from moles to grams. Okay, now that we've got our mole map up here, we're going to go ahead and get started. So we've got 4.55 times 10 to the 23rd atoms of aluminum. We're going to convert to moles of aluminum, so that goes on top, moles of aluminum. But I need to get rid of this atoms of aluminum, so I'm going to move that down on the bottom, atoms of aluminum. Now atoms per mole should tell us that that is Avogadro's number. It's the same thing as particles per mole. And it's always 1 mole, so I need to put Avogadro's number right here. And I'm afraid I didn't write enough room. So 6.02 times 10 to the 23rd goes right there. Okay, we have an atoms of aluminum on top divided by an atoms of aluminum on bottom, so they go away, they cancel each other out, and we are left with moles of aluminum. So we're at moles of aluminum, now we need to go to moles of aluminum sulfite. So I'm going to put moles of aluminum sulfite on top, because that's where I need to go. Wherever you need to go is the one that goes on top. Okay. Now we need to get rid of this moles of aluminum. So I'm going to put it on bottom. Now we have moles of aluminum sulfite, moles of aluminum. Now they're two different things, but they're the same units. So what we're going to do is we're going to say for every 1 mole of aluminum sulfite, how many aluminums are there? Well, there are 2 aluminums. So for every 1 mole of aluminum sulfite, there are 2 moles of aluminum. So we have moles of aluminum on top, moles of aluminum on bottom. They cancel. We're at moles of aluminum sulfite, which is where we want to be. Now we need to go to grams of aluminum sulfite. So I'm going to put that on top. Grams of aluminum sulfite. I need to get rid of this moles of aluminum sulfite, so I'm going to put it on bottom. And I'm looking right here, grams per mole. That right there tells me it's molar mass specifically of aluminum sulfite. Now the molar mass of aluminum sulfite, hopefully you guys know how to do that by now, so I'm not going to go through the steps, but the molar mass of aluminum sulfite is 294.17 grams in 1 mole. So we have a moles of aluminum sulfite on top, a moles of aluminum sulfite on bottom, so they cancel out and they go away. The only units that we are left with is grams of aluminum sulfate, and that's what we want to be at. We want to end with grams of aluminum sulfite, I apologize. We want to end with grams of aluminum sulfite, and that's what we've ended with. Now all we have to do is multiply 4.55 times 10 to the 23rd times 1 times 1 times 294.17 divided by 6.02 times 10 to the 23rd divided by 2, and then we will get 111 grams of aluminum sulfite for every 4.55 times 10 to the 23rd atoms of aluminum. Now I would like for you to pause the video and try this practice problem on your own, and then come back, start it back up again, and check it. Okay guys, here's your answer. Go ahead and check it and check your work.